So let's open that up for a few seconds. All right, so let's say, for example, if we wanted to evaluate say the integral of 5x squared plus 20x plus 6 all over x to the third plus 2x squared plus x. So clean that up a little bit. Yep, with respect to x. Okay, so the first thing you want to look at is your denominator. You want to see if you can factor it out. Okay, so you know x to the third plus 2x squared plus x. You can actually start off by factoring out the x, which gives you x squared plus 2x plus 1, where you now have x times x plus 1 squared. Okay. So this is your repeated linear factor. Okay. And actually this x isn't repeated, but it is linear and it is distinct. Okay, which is what we went over last time. Okay, so that means 5x squared plus 20x plus 6 over x times x plus 1 squared. You will start off with your a over x because it's distinct. It gets its own a. Plus b over x plus 1 plus c over x plus 1 squared. Let me clean that plus sign up a little bit. Okay. So if you had x plus 1 to the third power, you would have b over x plus 1 plus c over x plus 1 squared plus d over x plus 1 to the third. So you just keep going up, depending on how high your degree is. Yes?
Will you always have a distinct x?
Not always. It kind of depends on what's down there. So it's, I think on a lot of the problems you will. Okay. But whenever you have your repeated factor, you'd have your distinct with its own variable. Right. And then you just have the ones for your repeated.
Is there ever more than one distinct, or distinct is singular? There's not
more than one? It could be more than one. It kind of depends. So you could have x times x plus 1 times x plus 3 squared.
Okay, so that would be two distinct and then...
Yep, exactly.
Okay.
Yep. All right, so we're going to come back to this later after we solve for a, b, and c. Excuse me. Okay, so now once we're here, we automatically have to get like denominators. So that means we have 5x squared plus 20x plus 6 over x times x plus 1 squared equals, give this a little bit of space, a over x. So here we're just missing the x plus 1 squared. So we multiply this by x plus 1 squared over x plus 1 squared. Plus b over x plus 1. The only thing missing here is another x plus 1 and an x. So we multiply this one by x times x plus 1 over x times x plus 1. Okay. Now for c, you have plus c over x plus 1 squared. The only thing missing is the x. So you multiply this one by x over x. Okay. So now you know if you multiply both sides by the common denominator, all the denominators will cancel out. So that leaves us with 5x squared plus 20x plus 6 equals a times x plus 1 squared plus b times x plus 1 plus cx. Okay. So it's that part we start to use our strategic substitution. Okay, so now if we start off, if we let x equal 0, we'll get rid of b and c. And this way we could solve for a. Okay, so we'll let x equal 0. Okay, so that gives us 5 times 0, which is 0, plus 20 times 0, which is 0, plus 6. So you have 6 equals a times 0 plus 1 is just a. That becomes 0 and that becomes 0. So we actually end up with a equals 6. Okay. So if we let x equal negative 1, we'll get rid of b and a, and we'll be able to solve for c. Okay. So if we let x equal negative 1, negative 1 squared is 1. So you have 5 times 1, so you end up with just 5. Plus 20 times negative 1, so you might as well say minus 20. Plus 6 equals, if you plug in negative 1 here, that becomes 0. If you plug in negative 1 here, that becomes 0. So you have c times negative 1, or negative c. Okay, so you end up with negative 20 and it's 9. Okay, so that should be 11, so that's negative 9. So negative 9 equals negative c, or just c equals 9. Okay, so we have our a and we have our c, so we just have to solve for b. Only problem is we've used up all of our strategic substitutions. Okay, so we already used up 0, we used up negative 1. So now you can really just plug in something that would make it easy to solve for b. Okay, because we can easily plug in 9 for c and a for 6. So you can probably use x equals 1. Bless you. Okay, so no more strategic substitutions. So just pick a convenient one. Bless you. Okay, and also don't forget your A and C. And we'll continue this one on the next page. There's no way in the world I'm going to finish this on one sheet. Leave that up for a few more seconds. So if we continue here, okay, so we'll just let x equal 1, just random, any value. If you want to make x equal 100, you could, just dealing with bigger numbers. Okay, and we know that our a is...
You're a little high up on the screen.
Oh, thank you. Okay, so we know we have a equals 6, and we solve for c equals 9. Okay, so if we plug everything in, we have 5 times 1 squared plus 20 times 1 plus 6 equals 6 times 1 plus 1 squared plus b times 1 plus 1, and our c, x, just becomes 9 times 1. Okay, so we end up with 5 plus 20 plus 6 equals 2 squared is 4, so that's 24, plus 2b plus 9. Okay, so we have 31 equals 33 plus 2b. Like that, that becomes negative 2. So 2b equals negative 2. So we know that b is equal to negative 1. Okay, so we have our a, we have our b, and we have our c. So now we just go back to the formula we marked here, plug in our a, b, and c, and we'll be able to integrate each one of those separately. Okay, so we know that 5x squared plus 20x, well, we kind of separate that a little bit, plus 6 over x times x plus 1 squared is equal to a over x, so that's 6 over x, or you can make it 6 times 1 over x, plus b over x plus 1, move that here to kind of hopefully, okay, so b over x plus 1, so our b is negative 1, so we can make that minus 1 over x plus 1. Clean that up some. Plus c over x plus 1 squared. So that would be plus c, so that's 9 times 1 over x plus 1 squared. Okay, and we can go ahead and actually just integrate from there instead of rewriting everything. Okay. Now for these two, they're just going to end up being natural logs. But for this one, you just let u equals x plus 1, where du equals dx. So you actually end up with the integral of u to the negative 2 du, which is u to the negative 1 over negative 1, which ends up giving us 1 over, or negative 1 over u. Okay, so negative 1 over x plus 1. Okay, so this ends up equaling, give that a little bit of space, 6 times natural log of x when we integrate that one, minus natural log of x plus 1, minus 9 times, or might as well put 9 over, u, which is our x plus 1, plus c. All right. So that would be your final answer for that one. So a little bit lengthy, but not horribly long. All right. Any questions on this one? All right, leave that up there for a few seconds. All right. looks like. Okay, so let's say, for example, we want to evaluate the integral of 1 over x to the 4th plus 2x to the 3rd with respect to x. Okay, so the first thing we want to do is factor our denominator. So x to the 4th plus 2x to the 3rd. You can actually just factor out an x to the 3rd. So you end up with x plus 2. Okay. Now, actually, this one is our repeated linear. And this one is just our distinct linear. Okay, so we just rewrite that as 1 over x to the 3rd times x plus 2 equals a over x plus b over x squared plus c over x to the 3rd plus d over x plus 2. Okay. Once again, we know we're going to come back to it once we solve for a, b, c, and d. But for now, we just have to match our denominators. Okay, so that means we have 1. Uh-oh, a little bit longer than I needed that one. Over x to the 3rd times x plus 2 equals, move that over a little bit, so a over x. The only thing missing here is an x squared times x plus 2. So we multiply that by x squared. Oh, give that a little more room. X squared x plus 2 over x squared.
X cubed.
Nope, because it's already x.
Oh, I see. What
Yeah.
you mean. Okay.
Yep, we just want to match
I'm
it.
writing it differently.
Okay, so plus b over x squared. The only thing missing here is an x times x plus 2. Plus c over x to the 3rd. Only thing missing there is the x plus 2. So we multiply that by x plus 2 over x plus 2. Plus d over x plus 2. The only thing missing is the x third. So it's times x to the 3rd over x to the 3rd. Okay, so as soon as you multiply both sides by the common denominator, those disappear. So you end up with 1 equals x squared. Oh, might as well leave it right there. Put the a in front now. Ax squared times x plus 2 plus bx times x plus 2 plus c times x plus 2 plus d times x to the 3rd. Okay, so now we use our strategic substitution. Okay, so first, if we let x equal 0, it'll get rid of this one, and this one, so we can solve for c. Okay, so you let x equal 0, you end up with 1 equals, that becomes 0, that becomes 0, that becomes 0, c times 2. Which means we have c equals 1/2. It's problems like this where 0 is my favorite number. Okay, so now we can pick x equals -2. X equals -2, we get rid of this one, this one, and this one, and we can solve for d. Okay, so you end up with 1 equals, this disappears, and this disappears. So it's dx, -2, forgot about that, to the third. Okay, so -2 to the third is -8. So you get 1 equals -8d. So d is equal to -1/8. Okay. Now with this one, we can't just pick a value of x because we have more than one unknown value we have to solve for. So even if we did pick a value of x, we still have a and b, so that wouldn't help us out in any way. Okay, so this time we're going to actually use a method of, they call it equating coefficients. So we don't have any other strategic substitutions. Oh, sorry about that. We can use. So we use the method of equating coefficients. Okay, it's a little bit different, but it's not horribly bad.
So it was bad.
Not really. I don't think it is. Like I said, it's just something different. All right, I'll leave that up for a little bit so we can continue on the next page. Excuse me. I'm still writing. All right. Now the biggest drawback is we're going to have to now distribute all of those. Oh. All right, so if we continue, bring that down, son. On the next page, and write out exactly where we are. So if we have our 1 equals ax squared x plus 2 plus b times x, x plus 2 plus c times x plus 2 plus dx to the third. Okay, so we're just going to go ahead and distribute to get rid of our parentheses. So that gives us 1 equals ax to the third plus 2ax squared plus bx squared plus 2bx plus cx plus 2c plus dx to the third. Okay, so now what we're going to do is we're going to put all of our, I guess you could say, common exponents together. So all of our x thirds will go to our x thirds. Our x squareds will be next to each other. So you're going to put all of them together. Okay, so 1 equals ax to the third plus dx to the third. Okay, so we can kind of run a little line through those. Plus 2ax squared plus bx squared plus 2bx plus cx plus 2c. Okay. So now we're just going to factor out the x third from here. We're going to factor out the x squared, and we're going to factor out the x, while at the same time putting in kind of like filler values on the left side. I'll show you what I mean by that. So if we have 0x to the third plus 0x squared plus 0x plus 1, all we did was rewrite the left side but put in 0 values, equals a plus d times x to the third plus 2a plus b times x squared plus 2b plus c times x plus 2c. Okay. So we know in order for these to be true, for x cubed to match x cubed, we know that a plus d has to equal 0. So we know for this to be true, your x squared to match up, 2a plus b has to equal 0. Okay. In order for this to be true, next to your x variable, 2b plus c has to equal 0. And we know just for your constant, 2c has to equal 1, but we already know that for c is equal to 1/2. I think we already figured that one out, so we don't really need that one. Yep, we already figured that one out, so we don't really need that one. Okay, let me write down which ones we already did solve for. Okay, so we already know that c is 1/2 and d is 1/8. So let's negative 1/8. Thank you. Okay, so we know that c equals 1/2, d equals negative 1/8. Okay, that's already solved. So now all we have to do is plug in here and we can solve for a. Okay, so that means that a plus negative 1/8 or a minus 1/8. All right, so do that instead of making it more complicated. A minus 1/8 equals 0, which means that a is equal to 1/8. Okay, so we have a, we have c, and we have d. All we need are b. Well, all we need is b. Okay, so we know a is 1/8. So we know 2a, or 2 times 1/8, plus b is equal to 0. So if we subtract, I guess you might as well call it 1/4. 1/4 plus b equals 0, so b is equal to negative 1/4. Okay, we already have c, so we don't even need that anymore. So we can just kind of ignore that one. Okay, so we have our a, we have our b, we have our c, and we have our d. Okay. Any questions on that method? Yes.
Is there a quick way to like double check that? Say you mess up in the steps of like getting the correct exponents together. Is there a quick way to check that?
I think could you plug in the letters A, B, C, and D, and then some random X value?
Yeah, if you plugged in